Nanocoatings, coatings with a thickness hundreds of times smaller than a human hair, have become ubiquitous in modern technology. Hydrophobic coatings have been implemented into self-cleaning windows, anti-corrosion technology, filtration advancements, and more, which you will find in hundreds of products every day. However, mass production of nanocoatings is limited so far. Current laboratory methods typically rely on spin coating. With a spin coater, the creation of highly uniform, thin coatings is achievable. However, spin coating is not a scalable method and wastes 90% of applied coating material, making it unreasonable for commercial applications. If we want to move these technologies into the real world, we need a better solution. There is a need for a module that can maintain the same quality of thin, uniform films, but on an industrial scale. The opportunity for growth in the nanocoatings market is massive. In fact, it's projected to expand from around $1.8 billion in 2024, driven by a remarkable 18.7% compound annual growth rate. The demand for nanoparticle coatings is clear, but to truly meet it, we need scalable, efficient manufacturing infrastructure. Without it, these advanced materials can't reach their full potential. Our team set out to answer this critical question. How do we scale nanocoating production sustainably without sacrificing quality? Designed for consistent, high-quality application on flexible substrates, our solution, a roll-to-roll module, delivers uniform coating thickness with reliable performance while still preserving desired surface qualities such as porosity or roughness. This system replaces spin coating with a doctor blade design, dramatically reducing material waste and enabling continuous, high-throughput processing. This finely adjustable doctor blade is engineered to provide control over wet film thickness and coating edge quality. From slurries to inks to functional fluids, this setup ensures smooth, stable application every time. The module features precise tension control for the substrate and seamless integration with the curing chamber, making it ideal for both R&D environments and pilot-scale production. We focused on engineering a module that delivers on precision and reliability. A hydrofoil impeller within the reservoir maintains nanoparticle dispersion, and then the suspension is gravity-fed to the doctor blade coating head, while regulated through needle and solenoid valves to be applied evenly through a nozzle at the desired thickness. The solenoid allows for real-time control based on sensor feedback, and micrometer screws allow precise adjustment of the coating gap. It's quickly dried by passing through an IR heating chamber, accelerating water evaporation for fast curing. Our current system prevents clumping, improves consistency, and supports nanoscale accuracy over up to 3 inches substrate width. With automation, feedback controls, and minimal operator input, we anticipate substantial time savings and consistency on the industry scale. But technology doesn't exist in a vacuum. We asked ourselves, who's impacted across the entire life cycle of this system? From raw material sourcing to end-of-life disposal, we considered risks such as unsafe working practices and environmental pollution. By automating the coating process, we're able to reduce direct exposure to potentially hazardous materials, helping to protect factory workers and create a safer, more responsible production environment. Through using materials that are recyclable for the bulk of the product, such as aluminum and steel, we also reduce our carbon footprint, especially when compared to more plastic modules like spin coaters. To make sure our system could deliver on its promise, we conducted a rigorous set of engineering analyses, from heat transfer to structural and tensile tests to fluid mechanics assessments. Through a combination of analytical modeling, prototype testing, and iterative refinement, we've built a system that's not just innovative, but engineered for scale, reliability, and real-world impact. So why does this matter? Because without scalable, sustainable manufacturing methods, groundbreaking coatings will never leave the lab. Our system unlocks access to nanoparticle coatings for real-world applications, from healthcare to energy to consumer goods, while minimizing waste, risk, and cost. We're not reinventing the coating, we're reinventing how we apply it, and that makes all the difference. Our roll-to-roll module bridges the gap between discovery and delivery, enabling innovation that's not only scalable, but responsible.